For the second part of lesson 1.4, we're going to be dealing with solving quadratic equations. So solving quadratic equations is slightly different than factoring trinomial expressions. So the difference, remember, an equation has the equal sign, an expression is not to be solved, and it does not have an equal sign. So in our example here, I would like to recall that we can factor a trinomial. Notice that this trinomial does not have a equal sign. So there's no equal sign, which means we're not looking to solve for x. We're just trying to break down the trinomial into two binomials. So one of the skills that we learned earlier on, or one of the little tools that we were using, is to take the a and the c value and multiply them, put the b value down here, and then we're going to find two factors that make up a times c and add to b. All right, and then we're going to divide by a. So this is the skill that we learned in class, and if you would please try this out. So what we're going to do is we're going to take a times c, 4 times 5, and that's going to be 20. And 12 is our b value. And now we're looking for two numbers that multiply to 20 and add to 12. So I picked 10 and 2 because 10 times 2 is 20, but 10 plus 2 is 12. And now I have to get my a value and divide that into each of those factors. And if I go ahead and simplify this, simplifying my x, I'm going to be able to get my two binomials. So nothing changes about these numbers, but I can reduce 10 over 4 to 5 over 2, and that is the one that's going to have the x with it, the bottom number. And then this can be reduced to 1 over 2, and that's also going to be the one that I put my x with. So to finish, I'm just going to say 2x plus 5 and 2x plus 1 are the factors of this original trinomial expression. Now notice that I'm not saying x equals something. That was not the task that I set out to do. My task was just to factor, and I did that by getting these two binomials. Those are the factors, and I could check to see if it's correct if I FOILed. If I took 2x times 2x, I would get back to 4x squared. If I did the outside, etc., the inside, and the last, that's the way that I can check to make sure that my factoring job was correct. All right, let's take a look at example number 2. In example number 2, it says find the zeros, the roots, or the solutions. Now, we also call these x-intercepts. Okay, so it's going to be where the quadratic, if we were to actually graph the equation, this is another way for us to find the x-intercepts, or where the graph is going to hit the x-axis. So the first step is for us to set y equal to 0, or get one side equal to 0 by undoing. So we may have to change some things around or get everything to one side. Step 2 is to factor. Okay, so that's what we did in our example 1. We know how to factor. We're just finding two binomials that we can set equal to 0. All right, and if you have to, find that yellow sheet that you have that has that flow chart on it to help you figure out how to factor. And then step 3 is to set everything equal to 0, each of the binomials equal to 0, to find the solutions. Another word for solution, 0. Another word for solution, root. Or you could call them x-intercepts. So all of those words can be used interchangeably. Our first example, A here, is already set to 0. Everything's good to go. We don't have to do anything to manipulate everything to get it to one side because everything's already on one side. So I can just go ahead and factor this, and to factor it, I'm going to get my x tool out, and a times c is negative 24, and my b term is just 10. Now I have to come up with two numbers that multiply to negative 24, but add to positive 10. And I'm going to use 12 and negative 2, because negative 2 times 12 is negative 24, but the two of those, when I add them together, it is 10. So now I'm going to divide by a, and in this case a is 3. And I'm just going to make another little x here so I can reduce my two fractions. The top and the bottom stay the same. My reduced fraction over here is going to be 4 over 1. And this is going to stay the same, so I have negative 2 over 3. Now the x's that I'm going to write in my two binomials are the numbers on the bottom of those two fractions. So my answer, in terms of the factoring anyways, this isn't the final answer because we were asked to find the zeros and the roots, but really we did factor so that we can find those zeros or roots. And here's my factoring job. Okay, so these are the factors, but in order to find the zeros, I have to set each one of these equal to 0. So if I take x plus 4 and set that equal to 0, and then 3x minus 2 and set that equal to 0, I should be able to subtract 4 here and subtract 4 here. That cancels. So one of my zeros is going to be negative 4. So the graph is going to hit the x-axis at negative 4 there. And if I add 2 here and add 2 here, that leaves me with 3x equals 2. And if I divide by 3, then the other x that I have found is 2/3. Okay, so these are my two zeros, or roots, or solutions. With problem B, it looks like we have a little bit of work to do because we can't leave 4x minus 5 on the right-hand side of the equation. So I'm going to subtract that, subtract 4x, and I'm going to add 5. Okay, so that has to then also be done to the right-hand side. All right, so that's going to cancel, that's going to cancel. And it looks like these are going to be combined because they both have an x, and these are going to be combined. So when I rewrite this, I'm going to have 5x squared minus 20x plus 20. Now that's going to be equal to 0 because all of this canceled, and that side now is 0. So I have something here, it looks like, that can be divided by 5. Each of these terms has a 5 in it, so I'm just going to divide by 5, which means I'm factoring a 5 out of this polynomial. And 5 divided by 5 is 1, so I'm left with just the x squared. 5 divided into negative 20x is negative 4x, and 20 divided by 5 is just 4. Okay, so when I saw that I had a greatest common factor amongst all of these A, B, and C items, then I can take that out and bring it outside of the parentheses. And now I simply have a trinomial to factor. Okay, so I'm going to factor this trinomial, and all I have to think of is two numbers that multiply to positive 4 but add to negative 4, and immediately x minus 2 comes to mind because negative 2 times negative 2 is 4, but if I add negative 2 plus negative 2, then that means I get negative 4. All right, now I'm not done. This is the factored form, right, but that's not my final answer because I've been asked to find the zeros. So I have to set that equal to 0. Now, since both of them are the same, I have less work to do because I've, just going to set one of them equal to 0. So to solve, I'm going to add 2 on this side, add 2 on this side, and therefore x is equal to 2. So there's my solution, my one root, and that's where the graph is going to hit the x-axis. All right, and our final problem that I'm going to do with you on this side of the paper is C. If I look here carefully, I don't have everything on one side. So I'm going to have to subtract 63 from both sides, which gives me this polynomial or trinomial. Remember, we have to set it to 0 so that it's an equation. And it looks to me like everything here, every coefficient and our constant is divisible by 3. So I'm going to take a 3 out, factor a 3 out. 3 divided into 6 is 2. And I'm just going to be left with negative x there because 3 divided by 3 is 1. And that's going to be set equal to 0. Now I have to factor this, okay? And since the a value here is 2, that does not allow me to just immediately make my two binomials, right? I have to actually use my x method. This means that there's going to be something else other than just an x in this space. Okay, so as soon as you see that this a value is not 1, that's when you have to bring out your x. And that helps you, your flow chart should help you decide that. So a times c is going to be negative 42 because negative 21 times 2 is negative 42. My b value is negative 1. And so I'm looking for two numbers that multiply to negative 42 but sum to negative 1. So I'm going to use negative 7 and positive 6. Negative 7 plus positive 6 is negative 1, but those two numbers multiply to negative 42. And again, I'm going to divide by my a value, all right, and then I'm going to simplify. The simplified form here is still negative 42 here. This is still this because I can't do anything with negative 7 over 2. That doesn't really reduce, but 6 over 2 reduces to 3 over 1. And remember, the bottom of this fraction here is going to have the x, or the coefficient, sorry, the variable with it. Okay, so my factored form of this equation is going to be 2x minus 7, and don't forget I had a 3. This 3 right here still goes out at the front. And then I have x plus 3, all right, and that all equals 0. So if I set my 2x minus 7 equal to 0, I'm going to get, when I do all my algebra here, 2x equals 7 divided by 2, and x is going to equal 7 over 2, which actually, if you want to say it in easier terms, is 3.5 because 2 goes into 7 3.5 times. So either one of these would be okay. Now I also have to do that same thing with x plus 3, right? I can't just set this one equal to 0. I also have to set x plus 3 equal to 0. Both binomials get set equal to 0. And x plus 3 equals 0. Subtract 3 on both sides, and x equals negative 3. Okay, so I have two solutions for problem C. On the back of your note sheet, there are 3 problems for you to try on your own. You may want to have your yellow flowchart paper with you while you look at this, or maybe rewind the video if you need to have some more time just practicing while you're watching me do those problems. But there are 3 of them for you to try. There should be solutions over to the right. I have asked you to write in your solutions. There may be one, there may be multiple solutions, so just keep working at it. A lot of this is, you know, just practice, practice, practice. You definitely will get better at it the more you try. So bring any extra questions that you have. You know, if you run into a problem with one of those where you can't get past it, just, you know, try your best, and then when you're in class, make sure you ask about each one that you have. All right, example 3 is a word problem. It also has a diagram, and I would suggest that when you work on this on your own problem, you try to draw a diagram as well. Hopefully the diagram will help just a little bit. So let's look at the diagram and read through the problem as well. It says a pool deck of uniform width is going to be built around a rectangular pool. So uniform width just means that the width of the deck is going to be the same on all the sides. So the pool itself is 20 by 15. Well, 20 times 15 is going to give the area of just the pool. And so that is going to be 300 square feet, okay, the pool itself. And it says after the deck is built, a total of 414 square feet will be occupied. So how wide is the deck encompassing the pool? Well, how wide means how far from the pool edge to the edge of the deck. So we're looking for this width here, all right, and that's going to be uniform around the entire pool. So they're not going to change, you know, the ends aren't going to have a different width of decking. All right, so we have to find the value of x because that is the distance between the pool and the edge of the deck. So if you notice, the x is written, you know, in the space that the decking is shown here. So on the one side, this side right here is 2x plus 15 because we have 2 x's. And this side is 2x plus 20. So that's going to give us the entire area and we already know that the area is 414 square feet. So if I write this as an equation, the width of the pool is 2x plus 15, the length of the pool is 2x plus 20, and we already know that the pool plus the decking is going to add up to 414 square feet. All right, so if we FOIL 2x plus 15 times 2x plus 20, we will end up with 4x squared plus 70x plus 300, and we know that that equals 414. Okay, if I need everything to be on one side, I'm going to have to subtract 414 from both sides so that it's equal to 0, and that's going to allow me to solve for x. So 4x plus 70x minus 114 equals 0. All right, well, it looks to me like we can at least take a 2 out of each of these because all of our numbers are even. So if I divide everything by 2, that means I'm pulling a 2 out, which just leaves me with 2x squared plus 35 minus 57. 2 divided into 114 is 57. So now I can use my x method to find out what are my two binomials, or how can I factor this polynomial. So negative 57 times 2 is negative 114. That goes at the top. 35 in the bottom. And I don't know this automatically, but I worked this out prior to starting this recording. And if I divide 114 by 3, I get 38. So 38 and negative 3 multiply to negative 114. And they also add to positive 35. So this is where I'm working right now. And I do need to divide by 2 because that was my a value. All right. And if I rewrite this, rewrite my x, I'm still going to have negative 114 here. This is going to reduce to 19 over 1, and that's going to be an x. And I can't do anything with this fraction, but at least it helps me come up with the two binomials that I'm going to have. So my binomials are going to be x plus 19 and 2x minus 3. Okay, those are my two binomials that I'm going to set equal to 0 and be able to solve for x here. So let me do that over here. X plus 19 equals 0. If I subtract 19 from each side, there's no sense in giving a negative value for that because we cannot have a decking that is a negative value. Okay, so this one doesn't make sense for the problem because this is a real life problem and we can't have a negative amount of decking. So that one doesn't work. But if I set 2x minus 3 equal to 0 and add 3 to both sides, I get 2x equals 3, and then dividing by 2, x is going to equal 3 halves. Okay, if I say that in a different way, x is actually going to equal 1.5 feet. Okay, so the space between the pool and the edge of the deck is going to be 1.5 feet. Remember to do this on your own problem. I suggested that you actually draw a picture of the rectangular stained glass window. And if you would like to go over this problem in class tomorrow, just make sure that you've made an effort so that I can help you through the parts that you don't understand.